For most people, ants are little more than insects marching across sidewalks, gardens, and kitchen counters. Yet beneath our feet exists one of the most advanced military systems ever produced by nature. Ant colonies wage wars involving reconnaissance, territorial expansion, chemical weapons, coordinated assaults, defensive fortifications, and even specialized soldier castes. These conflicts have been unfolding for millions of years. While humans developed warfare over thousands of years, ants have been refining theirs through evolution for more than 100 million years. The ant family, known scientifically as Formicidae, contains more than 14,000 identified species, with scientists believing thousands more remain undiscovered. Ants occupy nearly every continent except Antarctica and collectively represent one of the most successful groups of animals on Earth. Their total biomass is astonishing. Some estimates suggest the combined weight of all ants on the planet rivals that of the entire human population. Their success is built upon organization, cooperation, and perhaps most importantly, chemistry. Unlike humans, ants do not rely primarily on sight or sound to communicate. Their civilization is built on chemicals. Every colony functions through a sophisticated network of pheromones, chemical compounds that transmit information between individuals. Ants use these signals to identify nestmates, locate food, warn of danger, coordinate attacks, and organize complex social behavior. In many ways, an ant colony resembles a living chemical computer. This chemical communication system also forms the foundation of ant warfare. When rival colonies encounter one another, the first challenge is identification. Ants constantly inspect one another using chemical signatures that act like biological passports. Every colony possesses its own unique scent profile. The moment an ant detects an unfamiliar chemical signature, alarm systems activate throughout the colony. One of the most common weapons used by ants is formic acid. In fact, the word formic comes from the Latin word for ant. Certain species can spray or inject this corrosive chemical directly at enemies. Formic acid can damage tissue, interfere with movement, and create confusion during battle. For smaller insects, even tiny amounts can be devastating. What appears insignificant on a human scale becomes a powerful chemical weapon in the microscopic world. Wood ants are among the best-known users of formic acid. When threatened, they raise their abdomens and spray acid toward attackers with remarkable accuracy. Colonies can coordinate these attacks, creating concentrated chemical defenses that deter predators and rival colonies alike. Some researchers have described these defensive formations as biological artillery batteries operating entirely through instinct and chemical coordination. Other species employ even more sophisticated weapons. Trap-jaw ants possess jaws capable of snapping shut at extraordinary speeds. While this mechanical weapon is impressive, the chemical systems supporting colony defense remain equally important. Alarm pheromones released during combat rapidly mobilize nearby workers. Within seconds, hundreds of defenders may converge on a threat without any central command structure directing them. Army ants represent another remarkable example of organized warfare. These ants do not build permanent nests. Instead, they form massive mobile colonies that move continuously through forests. Their raids can involve hundreds of thousands of individuals sweeping across the landscape. Insects, spiders, small reptiles, and countless other animals flee when army ant columns approach. Their strength comes not from individual size, but from overwhelming coordination. Perhaps the most extraordinary chemical warriors belong to a group known as exploding ants. Found primarily in Southeast Asia, these ants possess a defense mechanism unlike anything found in human warfare. Specialized workers can rupture their own bodies deliberately during combat. When they contract certain muscles violently, their exoskeleton splits open, releasing sticky toxic substances onto attackers. The ant dies instantly, but the sacrifice may save the colony. Scientists refer to this behavior as autothysis. It represents one of the most extreme examples of self-sacrifice in the animal kingdom. Evolution has essentially produced living chemical bombs whose purpose is to protect relatives sharing much of their genetic material. From the perspective of natural selection, sacrificing one individual to preserve thousands of colony members can be advantageous. Chemical deception also plays a major role in ant warfare. Some species have evolved the ability to mimic the chemical signatures of rival colonies. By disguising themselves chemically, these infiltrators gain access to enemy nests. Once inside, they may steal food, attack brood chambers, or exploit colony resources. In human terms, this resembles espionage and sabotage conducted through chemistry rather than technology. Slave-making ants take this strategy even further. These species raid neighboring colonies, capture larvae and pupae, and transport them back to their own nests. Once the captured ants mature, they work for the colony that kidnapped them. The entire process depends upon manipulating chemical recognition systems. Without the ability to alter or confuse scent-based identification, such operations would fail immediately. Fire ants demonstrate another form of chemical warfare. Their venom contains alkaloid compounds capable of producing painful reactions in larger animals. A single sting is unpleasant, but coordinated attacks involving hundreds or thousands of workers can create significant defensive power. Fire ants use these chemical weapons to defend territory, protect nests, and compete against rival species. Territorial competition drives much of this evolutionary arms race. Colonies require food, nesting space, and access to resources. Because many ant species occupy densely populated environments, competition is constant. Any adaptation that improves survival gains evolutionary value. Over millions of years, this process has generated an astonishing variety of chemical weapons, defensive systems, and communication networks. Leafcutter ants reveal another dimension of chemical sophistication. These ants cultivate fungal gardens as their primary food source. Maintaining these gardens requires advanced chemical management. Colonies produce antimicrobial compounds that suppress harmful pathogens while protecting beneficial fungi. Some ants even carry symbiotic bacteria that manufacture antibiotics naturally. Long before humans discovered penicillin, ants were practicing forms of biological disease management. Researchers continue studying ant chemistry because it offers insights into medicine, materials science, robotics, and communication systems. The compounds ants produce often display remarkable effectiveness despite being generated by organisms only millimeters long. Understanding how these chemicals function may eventually inspire new technologies and medical treatments. The complexity of ant warfare challenges traditional ideas about intelligence. Individual ants possess tiny brains containing only a fraction of the neurons found in larger animals. Yet colonies collectively perform behaviors that appear highly sophisticated. Complex battles, coordinated defenses, resource allocation, and strategic adaptation emerge without generals, governments, or centralized leadership. Instead, these systems arise through decentralized decision-making. Each ant follows relatively simple rules based largely on chemical signals. When thousands or millions of individuals interact simultaneously, remarkably complex behavior emerges. Scientists often compare ant colonies to distributed networks where intelligence exists at the group level rather than within individual members. Climate change and habitat destruction may alter these ancient conflicts. As temperatures shift and ecosystems change, species distributions are changing as well. Colonies that rarely encountered one another historically may increasingly compete for territory. New battles are emerging as environmental conditions reshape habitats across the globe. Humans are not immune to the consequences. Invasive ant species have spread worldwide through global trade and transportation networks. Some species displace native ants, disrupt ecosystems, damage agriculture, and create economic costs reaching billions of dollars. Understanding ant warfare is therefore not merely a scientific curiosity. It has practical implications for conservation, agriculture, and ecosystem management. What makes ant warfare remarkable is that it evolved independently from anything humans created. No engineer designed these systems. No scientist developed their chemical formulas. Every weapon, communication signal, and defensive strategy emerged through natural selection, acting across millions of years. Evolution transformed simple insects into participants in one of the most sophisticated chemical arms races on Earth. The next time you see a line of ants crossing a pavement, remember that you are witnessing the surface of a hidden civilization. Beneath the soil, armies patrol borders. Chemical laboratories manufacture weapons, spies infiltrate enemy territory, and soldiers stand ready to sacrifice themselves for the survival of the colony. It is a world governed not by politics or technology, but by chemistry. For more than 100 million years, ants have fought wars most humans never notice. Their battlefields are measured in centimeters rather than kilometers. Their weapons are measured in molecules rather than missiles. Yet in terms of organization, efficiency, and evolutionary innovation, these microscopic warriors have created one of the most extraordinary military systems the natural world has ever produced. If you enjoyed this deep dive into the forces shaping our future, be sure to explore our other documentaries examining the technologies redefining modern civilization. And if you want to keep exploring the biggest questions about science, power, and the future of humanity, make sure to subscribe to the channel and join us for the next journey into the unknown.